So let's do an interesting problem. Okay. So what you would be given is you would be given a graph initially. Okay. Something like this. Now, let's say these are some 3, 1, 4. Okay. Uh, this is, let's say, the edge number E1, E2, E3. There are some edges. Okay. No weights. I'm just writing a kind of identifier for all of them. Okay. E6. Some edges are available. Okay. Now, again, what would be told you is like given a graph. Okay. Every time they will ask you some queries, two queries again. Okay. There are two types of queries. Okay. The first type of query is you have to tell me how many number of components are available. Okay. As same as what we have solved. But the second type of query is you would be asked to remove an edge. You would be asked to remove an edge. Okay. So say we have this graph. Okay. Let's say they kind of ask you to, so there is one more, E7. Let's say they kind of ask you to remove E3. Okay. They ask you to remove E3. If you remove E3, how many components are there now?
One, still one.
Still one. Let's say if you remove E2 now,
Two.
Two.
2, right? This is a separate and this is the entire P, correct? A wala, whole.
Yes.
Okay. So now you got two components. Let's say you're asked to remove E1. What happens? How many components?
Three.
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 Right. Okay. Let's say you're asked to remove E4.
Still three.
If you remove E4 also, you see there is this still connectivity available. So what about E6?
Four.
Exactly. So you're getting it right, what I'm trying to convey. So
Yeah, yes.
you
Yeah.
will be asked to remove an edge and you have to tell number of components.
Okay.
Is the question clear? Others?
Yes.
Uh, yeah, Devamana, Sam.
Yeah, yeah.
Yes. Yes.
Okay, so try to think for a minute and ask yourself, can we use DSU?
I think we can write a one more method called Primo like that instead of merge.
So in DSU, we only have the two methods, okay? There is no extra additional functionality which was given.
Okay.
Okay, so now, okay, let's not think of much because it kind of like if you have seen this trick, you know, otherwise you don't know. Okay, this is what the good part of this problem is. Okay, chalo, let's try to run on a small example. Okay, before that, what I asked you just now, you are given queries, correct?
Hmm.
Now, there are two types of queries, you know. In competitive programming world, there are two types of queries. One is known as, did anyone hear about this? offline queries and online queries. Does anyone know about this?
No, bro.
Okay. What about offline queries? What about online queries? So, as the name suggests, what do you mean by offline? Offline is you are already given a bunch of queries to you. Okay, let's say query array, something like this. Okay, you're already given some kind of queries array to you. Now, so I have to answer each of the queries on this, correct? This is the thing. If the entire query, if all the queries, whatever you will be given, is readily available at the first time itself, then it is known as offline query. Okay. Is the question clear? I mean, is the point clear? If
Yeah, yeah.
everything is ready with you beforehand, then it is known as offline query. The reason it is offline query is you can manipulate this. How you can manipulate this? Let's say you are asked to that query 1, query 2, query 3. I mean, programmers will compute this first, maybe this second, maybe this third. Why? Because you already have the entire set of queries available with you, right? So it might be that three might be dependent upon two, two might be dependent upon one. If you go in this way, you might not get the answer. But if you kind of, manipulate the order, there is a high probable chance that you can kind of derive the answer from this. Okay, so when you have the entire thing available with you at beforehand, this is known as offline queries. What about online queries? Online queries is you will be given query each time. Okay, each time in the sense at one point only one query, at one point only one query, you will not know the entire type of query. Okay, is the difference clear between offline and online queries?
Yeah.
Okay, so
At a time and one by one.
yes. So offline is you have everything ready with you at the first go, but online is you will be given once. I mean, एक बार करके. Okay.
Okay.
Now, so for offline queries, like if you go to competitive programming realm, like there are many beautiful techniques available. Okay, which is obviously the highest, the advanced algos. Okay. I mean, I've just seen, I have never learned them, but yeah. But online queries में तो भाई, since you are given, you should do at that time itself. Okay. In our case, okay, let's try to do this. I mean, let's try to solve for this graph. Okay, let's say initially you are asked to find number of components. Okay, so if I say two means number of components. If I say one and some ei, you should remove that edge. Okay, so let's say I got two initially. So how many, what is the component size now? Can I say one? Because there are only one components.
One. Yes.
Let's say I am asked one e3. One e3 means remove e3. So how many components?
One.
Still one.
Still one or two? What about
One.
one e4?
Two.
Two.
Okay. So what happened now is this is what we have, right? Because these two has been removed, correct? Now let's say two. So how many components? Two components, right? Uh, this is e2. This is e1. Now see,
Three.
after removal of one e1, okay. So there will be three, right? मतलब
Three.
BC. This is this is A, and this is D,
A and B.
right? So when you say two, you should return three components. Okay. Now these are the entire set of queries given to you. Okay. I wouldn't give you one at a time. I would give you entirely. Okay. So now we only know. So what's happening here is you're kind of disjoining them. I mean, you are kind of separating them, right? But what's union find? Union find is merging together, but here we are separating. Then how DSU can come into picture? What we learned is merging, but here we are doing this. Ab bolo.
Reverse.
Right, very nice one. Good. Glad to know that you have seen that. If you go in a reverse order, what happens? चलो देखते हैं, ठीक है? So this is the last state, right? This is my last state, correct? Now, if I ask the two, can I say the number of components available are 3? अरे हाँ ना बोलो भाई तुम. Others?
Yes, bro.
Yeah.
Yeah, I know.
Yes,
Yeah.
yes,
Able to see that. Others,
Yeah.
are you guys understanding or not?
yes.
Up. See, you are given queries in this fashion from top to bottom. But since we have all the queries available, I am going from bottom to top. Okay. Now when it is saying 1E1, okay, what would have happened if you go from top to bottom is you would have removed 1E1, right? But now instead of removing, can we say that we are adding? Because if you are going like this, मतलब past में जा रहे हो तुम लोग, ठीक है? If you are going in a past, 1E1 is removal, but if you're going like this, that means adding, right? So if it is adding, can I say this is this?
Yes.
Now, when it comes to, if it is 2, how many components are there now?
2.
When it is 1E4, 1E4 means adding of edge E4, correct?
Yes.
Right? Now, if it is 1E4, how many components are there?
Now it is 1.
Did we write something? Hmm, what happened was we were having A, okay? There was B, there was C, this D. Okay. So we kind of removed one E3. What is E3? E3, E4. How many components should be there?
Correct only.
No, if you go from back, okay. If you go from back, so can I say like this edge was like not affected anytime? BC, this was E2, right? So E2 has never come into our picture, right? So this was there as same as whatever we had earlier, okay? Now, when we connect one E1, what happened? What is one E1? This one. So the number of components are
2.
And did we get 2 here? I mean, 1 even if we query करने के बाद 2 आएगा क्या इस पे? We removed E3, E4 and E1, right? So this was removed, this was removed, this was removed.
3 will get.
You will have this component as a whole, this as a whole, and this as a whole. So we are kind
3.
of in the right track now. Okay. Now, when you have 2, you kind of know that you are done. What about 1E4? This is what I'm thinking of. Like, did I do something? Okay, let me check. 1E4. So 1E4 is what? What is 1E4? That is removal of edge E4, right? But now we kind of added it. Now what is 1E3? 1E3 is adding this. And again it's 2. 2 means what? Find number of components. So can you see we are getting a single component as a whole?
Yes.
Yeah.
Right? So instead of going in the forward direction, if you kind of go like this, okay, you kind of go in the reverse way, and since this is the forward movement, this is nothing but doing a reverse or the kind of opposite way, okay? That is, instead of removing edge, you know that everything was kind of after processing all these queries, you would have some graph. Okay. Now, if you just go in a reverse order, it's all about connecting, because what is the reverse way? Reverse way is just instead of removing, you're just adding it. Correct. So what's DSU? DSU can only tell you about union, right? It's merging, not disjoining them. So if you go in the reverse way and find number of components, can I say we are done?
Bro, one doubt.
Yeah.
Like we got there A, B, C, and D, right? Three
So
components we got after performing removal operations.
so one thing, Sam, is like whenever you are asked a two, you should tell number of components. Okay. It's when it is one, you should only like uh just remove that edge. Okay. Yeah. So now you're telling something about
Yeah, actually, if we go reverse,
mhm.
how we will be knowing that components one, bro?
Components
Like,
one means
like first initially we came from top to bottom, right? At
yes,
last at one E1 we got A, B, C, and D. These three components we are having.
correct.
From there we are combining, right?
Yes. So
We are giving complete graph now. How to go from the back and connect this all? Like
okay.
we don't know the disjoint components now.
So probably shall we see the code to make it
Yeah.
very
Yeah. Okay.
okay. So I kind of have that code ready. Okay. I mean it's a little not longer, but I have just written it back. So let's see. Okay, Sam, and then we can try to correlate whatever you are asking. Okay.
Okay.
So initially, can I say these are the setup, like number of nodes, number of edges, number of queries.
Yeah.
Edge is nothing but whichever is having an edge. Okay.
Okay.
Now marked is nothing but, so can you see there are some edges which got deleted and there are some edges which were not, right? So in this, can you see E2? It was never impacted, right?
Yeah.
Right, E2 was never impacted in our question. So what we will try to do is we will mark the edges whichever has been affected means whichever has been deleted. Okay, so
Okay.
I have kept a marked. Okay, now since we need to handle the queries offline, I am storing all of them. Okay, I'm storing all of them. Now go through the query. Okay, if it is of type 1 means we have to
Number of components.
find the what I have.
Components.
No. If the type is one, you have to remove it.
Oh, remove. Sorry. Huh.
So edge number is nothing but E1, E2, A wale numbers. Okay.
Okay.
So the number of the edge. Okay, and I am just adding it into the queries list. Okay, and since this is a one based, I made it as zero based. Matlab, 1 minus 1 is like 2 minus 1. So zero based indexing, right? So just to make it from one based indexing to zero based indexing, I have made like this. Okay. Is this if condition clear?
Yeah.
Okay. Sas, Deva, Manan.
Yes, bro.
Okay. And
Yeah, bro.
finally we have this. Okay. That is you need to find what? Uh, two means what? Removing and not removing. क्या किया मैंने भाई? Yeah. You should delete that edge. Not delete. X dot length equals to 1 component size. Okay. What's the number of components? Okay. So if the type is 1, that means you have to uh, delete it, otherwise you need to find the number of components. Okay, so I have taken all the queries at the start itself. Okay, now
Bro,
see,
how we have taken edge number, bro?
edge
For
number
edge.
is 0 1 2 something like that. Okay, so this is the edge, right?
Yeah.
So edge of I0 I1 is this only, matlab A and B and C. What is an edge? Edge is an association between two nodes, right? A
Yeah.
and B. So I will take AB, I will take BC. This is edge 0. This is edge
Yes.
1.
Like how you are assigning numbers that I'm asking. Like what's
No,
A,
number
B
is
is.
index. It's index. Number is index. This is node 0, man. This is node 1. This is node 2, node 3. Okay.
Yeah.
Let's
Yeah.
say they give 2 comma 3. This is 0th index. This is first. second, something.
Okay. Okay. Okay.
Okay. So is this clear till here?
Yes.
Okay. Now we have
Yes.
a DSU
Yeah.
ready available. Okay. Now what I need to do is, so can you see there are some edges which were not affected in our graph. So if it was not affected, if it is not marked, can I say I need to merge them? Ab, what's the condition of DSU? The condition is this only, right? Initial setup of DSU is this only, right?
Hmm.
Hmm.
Right. In the case B and C, let's say this is C, BC was never affected. So can I say I have to, this is my setup now,
Yeah.
correct? Because this edge was never been affected. That means it will be there even after all the queries are performed. So in that case, whatever the edges which is not been marked, I mean it will always be there, which is not been deleted, I will merge them. Now is it clear?
Yes.
Yes.
So got it.
Okay. Now we have the answer. We need to kind of print the answer. So now you see I'm going from the back. Can you see this?
Hmm.
Instead
Hmm.
of going from 0, I'm going from the back. Okay. And what I have is queries. If the length is 1, that means if there is 1, please find the get component size. Get component size is nothing but return number of components.
Okay.
The same code, whatever you have seen. Okay. The same code. It will return the number of components. Otherwise, what we need to do, can I say we need to merge them?
Yeah.
So since it is a one based, I am just doing it minus minus so that it will become 0, 0 based, and edge number 0, edge number 1. That's all. Merging them. Okay. And remember, since we are storing the answer from back, at the last we need to reverse the answer vector or answer list, because we have solved from this fashion, right?
Hmm.
But we need to print the answers in this order, right?
Yes.
So we will reverse the answer list. Okay. Now is it clear? Or
Yeah.
shall we write a live code?
No.
समझ आ
Yeah.
गया?
That's fine. Yeah. That's fine, bro.
What about Deva? Is not
Yeah.
responding.
Yeah. Yeah. Okay, bro.
अरे तुम लोग को confidence नहीं आया. I understood that. I mean, at least Sas and Sam feels a bit confident, but Deva and Manan still have that. Which part you guys didn't understand? Can you tell me? अरे don't compare others, man. It's you guys are paying. You have the privilege to ask anything. This won't again. You won't kind of see this question again. I mean, most probably you won't be getting an explanation for this probably. So if you have anything, let me know now. Not only them, Sahas and Sam. If do you
No,
guys have anything on this?
no, bro. I got it.
Okay.
Yeah.
So you guys have to write this code and send me. Okay.
Yeah. Okay.
ठीक है. अब ये नहीं कि वीडियो रिकॉर्ड हो गया. देखिए.
Manan Bhaiya copy.
चलो. ठीक है. Is it clear?
Hmm. Yes.
Okay. So this is about DSU. Okay. So you remember I was talking on the last session that maybe we will learn something about merging. Okay. So this is it. Now I'll just give you a little bit of glimpse on one question. Okay. And maybe you can try to solve it later. Let's say you're given a tree. Okay. And each having an unique weight assigned to an edge. What you have to tell is, okay, that is for each pair, so you got the meaning of double summation, right? For each pair, okay? For each pair, you have to
Hmm.
Yeah.
d of ij. And what is d of ij? D of ij is the minimum edge value from I to j. Let's say I is here. Let's say j is here. What is the minimum value in this path? From
So,
minimum value
3.
3. To find it for all the different pairs. Okay. Let's say this is here. So in this case also it's 3. What about these two nodes? Since there is only one, this is 5. What about this and this? From this path,
oh,
which is the
1.
minimum? 1, right?
1.
So 1. So you kind of have to find for all the pairs, okay? And you have to report this summation. This is this kind of question appears in you remember there is this hard
control.
test. No, there is this hard test of some company, Infosys or something. They will ask very hard.
Into it. Into it, na?
Infosys, which will give less salary and they will ask some hard question. Infosys.
Hack in fee.
Yeah.
Hack in fee. फिर और कौन ना?
Just wait for a minute. Someone's at the door. Let's see. Till then, can you guys think of this problem? Yep. So, did you guys think of it? Something? Hello? Am I audible?
Yes, bro.
Yeah. So, what I was mentioning is not, it's about Infosys only. Okay. Infosys make there is very, in college days, didn't you, some power program or something? Didn't you guys give that
Power programmer.
something? And so,
Code Vita.
Code Vita is TCS, so that's also a hard one. But so this kind of question comes in those category. Okay, so a hard version. Now, so I'll give you a little bit of glimpse. Okay, so initially, let's say, ठीक है, तुम लोग सोच के like somehow do you guys think there is a contribution like 1 का
Yes.
contribution कितना है, 3 का कितना है, 4 5.
Yes, bro.
So if you start from the maximum weight, okay, if you start from the maximum weight, let's say all the nodes are kind of dislocated initially. So can I say if I go from maximum weight, let's say the weight is 5, can I say there will be only one?
Yes.
Yes. And what's the next maximum? Let's say the next maximum is this one, right? Now can I say the size here is 2, the size here is 1, correct? So if I do this, 1 into 2 is 2. That is, the contribution of 4 is 2, which is true because you can go from here to here or you can go from here to here. And in both of them, you will get minimum as 4. So can I say the contribution of 4 as 2? That is,
Yes.
okay. Let's say this one 3. Okay. So you guys have to tell me 3 is this. So can I say there will be 3 paths? One is this path, one is this path, one is this path. Correct. So how are you getting that very instantaneously? It's very simple, right? The size of this is 3. The size of this is 1. So 1 into 3 is 3.
1 into 3.
And finally we have this. So now all the nodes got merged. Okay. And how many? This is having a contribution with how many? 4. Correct? Because you have to.
4.
So this is 4. No.
4.
So can you see the contribution of 5 is 1, the contribution of 4 is 2, the contribution of 3 is 3, the contribution of 1 is 4. So if I somehow write this, is my answer done? क्या बोलते हो?
Yes, bro.
What about others? Did you guys understand? Manan?
Yes, yes.
Yeah.
Hmm.
Yeah. Sam left the meeting.
Okay.
He's not there.
So like it's easy, right? Ki initially all the nodes are DSU, matlab disjoint. Okay.
Hmm.
Go through each of the edges in a higher order, I mean decreasing order. For each of the edge, okay, what you need to do is, let's say this is the one, this is the one, okay. What you will do, root of x into root of y, correct? I mean size of
Yeah.
root x into size of root y into the edge value. Is this the equation which we get for all the edges 0 to m minus 1?
Yeah.
Sas, is it clear? Or shall we write the code
Yes, bro.
if it's needed? What do you guys say? What do you guys say? Shall we write or shall we move to the next concept? I mean, this is simple DSU only. So,
I did not get this. Can you scroll little below?
uh-huh.
S of root x into S of root y.
Okay, see, Sas. So, let's say we merged these 3, right, initially for node, for H2,
Yes.
for H1.
Yes.
Let's say we are talking about 3, okay. When we are talking about 3, this is the representative one, this is the representative of 1, correct?
Yes.
And this is for this component, this is the representative, correct? So can you see the size of this component is 3, I mean of this representative is 3?
Yes.
Can you see the size of this representative is 1? So what does this mean? Anything if you start from here, anything if you end it here, all of them will have an edge, minimum edge of 3, because we are going in the reverse order of decreasing weight. Can I say that?
Yes, bro.
Correct, right? So
Yeah.
if this is, how many components? 3 components. How many components? 1 component. So can I write 3 into 1? That is the contribution for this. And who is contributing?
Yes.
Can I say 3 is contributing?
Hmm.
So
Exactly.
fine.
So, like, I have a doubt. Why are we taking multiplication of 1 again? Like, anyhow, it's gonna be 1, right? Yeah.
Yeah,
All times it
nice.
will be 1, right?
Let's see this. Let's say we are joining this. Okay, let's say we are joining this now. When we are going after 6, 7, 4, 5, let's say we have to merge 2. Now, what's the size of this? What's the size of this? This part?
6.
No, size. I mean, this is not there now. This is not there. So can I say 3?
Okay, three. Yes,
How many here?
3.
So are there 9 nodes which are having a minimum of 2? Because let's see, this is one path, this is one path, this is one path,
Mhm.
this is one path. Can you see 9 paths totally? Can you see
Mm.
9 paths? Right?
So okay, yeah, got it.
Yeah. So
Yes,
see,
yes.
the size will the size will tell that I can start anything from here or anything from here. Okay. And since the contribution is 2, this is nothing but 18. And if you calculate manually, you will get 18 only. Okay. Clear now?
Okay, got it, bro.
Okay.
Yes.
So can you
Yes,
code it up?
yes.
Yeah.
Okay. Okay. So see, whatever these
We'll
are
try.
given, okay, uh, try to code it up because you have a mock coming up, and I might ask someone this question. So please.
Maranvai.
Darhamad by to
Hmm.
Okay. Chalo.
Yes.
Yeah.